Alright, so I'm going to record this problem. So this is how I would try to solve this problem if it wasn't a coding interview. I'm already kind of scared because look at how many thumbs down that this problem was given. So yeah, so 9:20 p.m. starting now. So first I'm going to read the problem. I have no idea what this problem is about. But it says write a function to check whether an input string is a valid IPv4 address or IPv6 address or neither. So as part of my conditions, is it IPv4 or IPv6 or neither? So 3 conditions. Also, I should probably list this will be my approach 1. Okay. Alright, very well. So IPv4 addresses are canonically represented in dot decimal notation, which consists of 4 decimal numbers, each ranging from 0 to 255, separated by dots. So here's an example of IPv4. So notice you have 1, 2, 3. Well, okay, we have 1, 2, so we have 3 decimal dots, and we have 1, 2, 3, 4 decimal numbers, which all range from 0 to 255. So 254 is within range of 255. 1 is within range of 0 to 255. Okay, so we have this. So we know what IPv4 looks like. Besides leading zeros, is invalid. So besides leading zeros and IPv4 is invalid. For example, the address. Sure. So when is IPv4 invalid? If you have a leading 0. Fine, I'm fine by this. Okay. Now let's read about IPv6 addresses. IPv6 addresses. So obviously, by the way, I'm probably going to be using regex in this problem. So I might just do this ahead of time, but I might import re, which is importing regex for Python. Okay, so IPv6 addresses are represented as 8 groups of 4 hexadecimal digits. 8 groups. So here we have 1, 2, 3, 4, 5, 6, 7, 8 groups. The colon, and these are all hexadecimal, which represent 16 bits. The groups are separated by colons. I mean, if they're representing 16 bits, then each one is 2 bits, right? The groups are separated by colons. For example, the address, so 2001 0 dB. So just remember that I think for hexadecimal it can be A, B, C, D, E, F. Let's see. I think that's what it goes up to. Hexadecimal. I might check this out later though. It's a base 16. It goes A to F. Okay, sure. Is a valid one. Also, we could omit some leading zeros among 4 hexadecimal digits. Some lowercase characters in address. Uppercase is 1. So is also valid. Oh, Jesus. It could be either lowercase or an uppercase letters. And it could be a mixture. Like, you might just uppercase a few of them. And you could omit some of the leading zeros. Interesting. So you're allowed to have leading zeros, but you can also omit some. Oh, man, I don't like this problem. However, we don't replace a consecutive group of 0 value with a single empty group using 2 consecutive columns to pursue simplicity. For example, is an invalid. Sure. Besides, extra leading zeros in the IPv6 is also invalid. Extra leading zeros, for example, is invalid. How is this an extra leading 0? Because it's greater than 4? Is it 8 groups of 4 hexa? Okay, because you have to have 4 hexadecimal digits, so this is too many. Note, you may assume there is no extra space or special characters in the input string. Okay. Example 1. Input is this. And I mean, looking at this, I can tell the output should be IPv4. This is a valid IPv4 address. Return IPv4. Example number 2. If this is a valid, so you can see it removes some of the leading zeros, but all of these are within the range of 4 hexadecimal digits in each little group. And also it did some of the uppercases, changed some lowercase uppercase. This is a valid IPv6. This is neither IPv4 nor IPv6. Okay, so let's see what we need to figure out here. So I don't know if it matters what order I do this in, but I might check if it is a valid IPv4 first. So to be a valid IPv4, we need to check on a couple of things. So first off, what conditions do we need to check? So I'm gonna keep track of what I need to check. So first thing I need to check is that there should be 3 decimal points and 4 numbers. 3 decimal points and 4 numbers. So I would check if it's a valid IPv4 first. So check if it's a valid IPv4 first. So I would check so 4, it's weird number, it's weird saying this, but 4 numbers. Okay, well, okay. I don't know what word I want to check in, but I think it's very important. There has to be 4 numbers, right? 4 numbers, which means there's going to be 3 decimal points, right? And then I feel like the next thing I would check is no leading zeros. And the third thing I'm going to check is each number within range 0, I guess I was right like this, num to 256, 255, okay. I think that's it. So no leading, so 4 numbers, 3 decimal points, no leading zeros, each number is within the range of 0 to 255. Now, if it satisfies all these conditions, you'd return IPv4. And then the second thing I'm going to do, I think that's all the cases, right? Check that there's 4 numbers, 3 decimal points, no leading zeros, each number. So I need to make sure that the 4 numbers are decimal numbers. Check there's 4 numbers, make sure they are decimal numbers. Is that how you say it? Decimal numbers? Yeah, decimal numbers. And yeah, so make sure they are decimal numbers. And there's 3 decimal points. I have no leading zeros, each number within the range, and return this if all of these are true. Right? Okay, so I think that's all that I would need for an IPv4. Okay, so it doesn't say there's going to be any special characters or any like extra spaces, so I'm not going to look into that. So then I need to check if it's IPv6. To check if it is valid IPv6. So to do this, I need to basically 1, 2, 3, 4, 5, 6, 7, 8. There should be 8 hexadecimal numbers. So I need to make sure they are hexadecimals. So that means they just need to contain 0 to 9 and A to F. And then I need to make sure that it's exactly 4. Wait a second. It has to have exactly 1 to 4 digits in each hexadecimal number, or you could say, or I would say group. Okay. So that'll be one thing I'm going to check. And then the other thing I want to check is, so checking that it's a 1 to 4 digits should work, because either you can have just a 0 or you can have 4 zeros. Like there's no problem. There's no problem with the leading 0. I'm not really going to check for any leading zeros. I'm really just checking that I have 1 to 4 digits in each hexadecimal group, and that they are hexadecimal numbers, and that I have 8 hexadecimal numbers. I believe there is no other restriction on this, so I think that's it. There's no range, so if these are true, we return IPv6 string. Alright, it's chugging along here. It's probably been 10 minutes now, so last thing, if all these fail, if both these fail, return neither, right? So that's it. So this is my build-up. This is my pseudocode, or not really even pseudocode, but this is my strategy to solve this problem. If I check all these conditions, it should work. I believe these are all the conditions. I don't think I missed anything, but this is how I would do this in a technical interview. Not worry about the whole coding it at the beginning, but just worry about what's the strategy, what are my edge cases, what am I checking for. So these are things I'm checking for. Now I can use this as a guide to actually code. So the first thing is I import RE. So okay, so the next step is I will get to looking at regex, and how can I use regex to start checking these conditions, each one. Alright, so yeah, I had a little bit of trouble with the regex here, but I think I finally figured out how to use it. So here we go. So I'm going to try to match this string here. This is a valid IPv4. So first off, I'm going to start with are the conditions. So first off, I'm going to specify that we're going to start, you would start with this, and I'm going to make everything a non-capturing group. So I have a non-capturing group. Where basically in this capturing group, I'm going to capture if the number is a 2. Sorry, yeah, if it's a 2 and a 5, then you can have any D. I think D is a, oops, wrong one. Return the match where the string containing digits numbers from 0 to 9, so it's anywhere from 0 to 9. I think I used the wrong direction though, a D like this. And because this is kind of upsetting, let's just look at what we've done so far. So we can match this, right? Or we could match to 4. And oops, my bad, this should not be any number, because if you have 2, 5, you can only have a number from 0 to 5 here. If you have a 2 and a 4, you can have any number, so I would put D. Or you can have a case where you have a, what's it called? You could have a 1. You could have a 1, 0. You could have a 1. 0 to 1 times. That is, you might have a 1, may not have a 1. And then you could have any, oops, then you could have any number. Well, I guess it would depend on if you have a 1 or not. So if you have a 1, you have any number. So like, yeah, if you have a 1, then you can have D, then you can have D, a number, you can have any number. Or you could have this, I guess, from 1 to 2. So if you have only 1 to 2 numbers, okay, so let's check this out. So that end case, I'm interested in. So basically saying if you have 1 to 2 numbers, it can be any number. It can be from 0 to 9, it can be 99. So my last or statement makes sense here. So it's just saying, and if you have 1 to 2, can we have 0? No, we can't have 0. Can we have nothing? That's just dumb. Can we have 199? Yes. Can we have 244? Oh, 244. Oh, this should actually be anywhere from 0 to 4. That makes more sense. So you can have 244, you can have 234, you have 253, you can have 256, no, you can have 257, okay. So that's what we started with. But now let's get to the point where we're going to need to emphasize that we can also have a period. I guess this is another group though. And we can have this 3 times. So this should match that. Cool, so this matches that. So at the beginning, we can have this. Now what can we have at the end? At the end, we want to have a number. So pretty sure it's just this. And then I think the symbol for the end is this. You don't actually need that. But if you don't put that, then it's possible that this will work. No. Is it possible that this will work? But it does help to emphasize that it has to be at the end. So 255.255.255.255. And then what if you have .255.255.255.255.255.255.255. Okay, so one match. I'll only get a whole match. Let's see if we'll match this. It shouldn't match this because okay. So it looks like this regex works. IPv4. And then we need the regex for IPv6. Let's get my example here. Before I do that, okay, paste. Okay, so to match this, it seems like it'll be kind of easy. So we're gonna have, I think I might do 2 capture groups. So one of these capture groups will basically just check if we have anything from a 0 to a 9, an A to an F, or an A to an F. And we can have this from 1 to 4 times. That's my first capture group. And I'm going to specify that this is at the start. And but then I want to check that we can have this. And we'll have this occur 7 times. Okay? Now to get a full match, so we have a partial match of a number, which kind of makes me suspicious, but basically what I'm going to do is add in this other result that we need. For instance, if I added this, it'd be no match. If I say we need to have, let's say, 7, 3, 3, or let's say we have 7, 3, 3, 3, 4, right? It says, oh, I match that. But then if you add these numbers, it's like, alright, cool, boom, no match. So you need to specify the end. So I'm definitely going to use this. But first, what can I have at the end? So what we can have at the end is this, right? So we have, because I'll do a not capturing group, 0 to 9, A to F, A in uppercase. I don't think I have to specify how many times it appears, do I? I can specify as 1 to 4. Okay. Now it's like, okay, cool, that works. Boom. Now it will only work. It will only match A if it's this. So this should work. Copy. Paste. Now the function that I'm going to try to use, I need to figure out what function to use. So if I go to here, search. Scan through string, looking for the first location where the regular expression pattern is a match. Return corresponding match. I return none. Okay, so searching for a match and return the match if there's a match. If there's no more than one match, only a first match will be returned. So this will return if there's a match. So I'm thinking if this returns none, it would be false, right? So like, I'm just going to basically use this condition here, if I can get it back. Python, I'm going to use the fact that none is false. Wait, what? None. Huh. I don't know why I did that. It's definitely false. It has a value of false, but I guess you can't say if none is false, but you can do it like this. So what I'm going to do is say if re dot search and I'm almost done. So do re dot search. I need the pattern and then the string. Okay. So the pattern is reg IPv4 and the string is IP. Basically, if this doesn't end up being true, then you just return IPv4. Okay, so this is following this condition here. If re.search reg IPv6 IP, then return IPv6, and then if none of this happens, then return neither. So let's check if this works. Okay, it accepts that. Let's see what it does if I add the rest of the examples here. And oh, that's my problem. Ooh, so it's supposed to be uppercase. Yeah, okay, I didn't look at that. Yeah, so it's accepted. So this definitely works. Yeah, so this is a good problem to solve, just to set up my approach. So I set up my approach. I tried not thinking about how I'm going to code it. I already had it kind of decided I'm probably going to use Regex. And then really just implementing Regex was the big challenge. I had to learn a lot about Regex to be able to do this. I learned about non-capturing groups. I feel like I never really understood this prior to doing this. And a lot of other stuff. But yeah, setting up this Regex is, it makes sense once you kind of figure it out. But yeah, so this is a good practice problem. Alright, it looks like I missed something. So it passes the case when you have a leading 0, which is not right. So it has to do with this code here. So here I said you could have any two numbers, but this is also going to allow a 0 in front. So actually maybe I just say you can have a number from 1 to 9, and then if you have a number from 1 to 9, you can have D, right? Or you can have any number like this. So that should work. So now it doesn't match this, because now what I'm saying is that you could have a condition basically where you have a 1 to 9. So like if I literally change all these to a 1, whoops, what's going on? Am I in insert? Change all these to a 1, 1, 111. Uh-oh. Why was it matching this? Right, because I still have this condition here. So I need to change this 1 to 9. D or D. Okay, so now what matches? It should match this. Okay, so it matches this. And then you can also have a single number. And it can be any number, so like 0, 0, 0. This should work. Okay, so this should actually work. Okay, submit. Yes, now it's done.